Good evening, sir. Myself G. Tabassum. I am from Electronics and Communication Department. In this video presentation, I am going to explain about effects of acid rain on the environment and its case studies. Subject name Environment Science. Subject code 23 NCM01. Let's begin this presentation. Effects of acid rain on environment. Introduction to acid rain. Acid rain is a term used to describe precipitation that has a lower pH than normal rainwater. It is primarily caused by release of sulfur dioxide SO2 and nitrogen oxide NOx into the atmosphere. These pollutants can originate from industrial emission, vehicle exhaust, and natural sources like volcanoes. Causes of acid rain. The burning of fossil fuels releases significant amount of SO2 and NOx into the air. These gases can react with water vapor, oxygen and other chemicals in the atmosphere. The resultant sulfuric and nitric acids then mix with rainwater, leading to acid rain. pH levels of acid rain. Normal rain typically has a pH of around 5.6 due to dissolved carbon dioxide. Acid rain can have a pH ranging from 0.4.0 to 5.0 or even lower in some cases. This difference can significantly affect ecosystems that are sensitive to pH changes. Effects on soil chemistry. Acid rain alters the chemical composition of the soil by leaching essential nutrients. Key minerals such as calcium and magnesium are often depleted, impacting plant growth. Soil acidity can also lead to mobilization of toxic metals like aluminium, which can harm flora. Flora means plants. Impact on water bodies. Acid rain can dramatically lower the pH of fresh waters, lakes, and rivers. This change can harm aquatic life, particularly species sensitive to pH fluctuations like fish and amphibians. In extreme cases, acidification can lead to death of entire ecosystem in affected water bodies. Effects on forest. Forest ecosystems are particularly vulnerable to acid rain due to their reliance on soil and water quantity. Acid rain can weaken trees by leaching nutrients and increasing susceptibility to diseases and pests. Some tree species may also experience reduced growth and reproductive success as a result. Impact on wildlife. Acid rain can disrupt the habitats of various wildlife species, leading to population declines. Species that rely on a specific pH levels in their environment may struggle to survive. This can result in a ripple effect throughout the food chain, impacting predator-prey dynamics. Effects on agriculture. Acid rain can negatively affect crop yields by altering soil chemistry and nutrient availability. Some crops may exhibit stunted growth or reduced resistance to disease due to poor soil conditions. Farmers may need to implement costly soil amendments to counteract the effects of acid rain. Damage to built environment. Acid rain can accelerate the deterioration of buildings and monuments, particularly those made up of limestone and marble. Historically, sites such as Asian temples and statues are particularly at the risk from acid corrosion. The maintenance and restoration cost of damaged structures can be substantial for municipalities. Human health concerns. While acid rain doesn't suppose a direct health risk to humans, its contributing pollutants do. SO2 and NOx can lead to respiratory issues and other health problems when inhaled. Vulnerable populations, such as those with pre existing conditions, may be particularly affected. Economic impacts. The economic cost of acid rain can be significant, affecting various sectors from agriculture to tourism. Decreased crop yields and damaged infrastructure can lead to financial losses for communities. Long term environmental degradation may also deter investment in affected areas. Migration strategies. Reducing emission of SO2 and NOx through cleaner energy sources is essential for mitigating acid rain. Implementing stricter regulations on industrial emissions can significantly improve air quality. Encouraging public transportation and electric vehicles can also contribute to emission reductions. International cooperation. Acid rain is a transboundary issue that requires international collaboration for effective solutions. Agreements like the 1991 Protocol on the Reduction of Sulfur Emissions have been established. Countries can work together to monitor emissions and share best practices for pollution control. Role of education and awareness. Raising public awareness about the causes and effects of acid rain is crucial for generating support for change. Educational programs can empower individuals and communities to advocate for cleaner practices. Engaging younger generation in environmental stewardship can foster long-term sustainability. Future research directions. Continued research into the long-term effects of acid rain on ecosystem is necessary. Innovative technologies for pollution reduction and soil restoration are areas of ongoing study. Monitoring programs can help track changes in affected environments and guide policy decisions. Case studies of acid rain effects. The decline of fish population in northeastern US lakes is a well documented case of acid rain impact. Forest dieback in a region like the Black Forest in Germany highlights the vulnerabilities of forest ecosystems. Studied in Canada have shown the correlation between acid rain and reduced biodiversity in sensitive habitats. Success stories in mitigation. Some regions have successfully reduced acid rain through effective emission controls and regulations. The US acid rain program has achieved significant reduction in SO2 emission since its implementation. Increased public awareness and community actions have led to improved environmental conditions in various areas. Conclusion and call to action. Acid rain poses a serious threat to the environment and human health, necessitating collective action. It is a vital for individuals, communities, and government to prioritize pollution reduction efforts. Together, we can work towards a healthier planet and mitigate the impacts of acid rain for future generations. Thank you.